All right, well, today we're going to go ahead and take a look at section 2.3. Here today we're going to be jumping into linear functions. Now, many of you have probably gone through content very similar to this. It might have just been called something different, or you may have seen references to lines, to slope, to point slope form, to slope intercept form, all these things. So today we're going to put a little bit more context into how linear functions work, specifically some notation, in other words, the way that we write, some of the math behind it, and then also we'll work through some examples so you can see how all of this kind of works together. So the first thing, again, a linear function. The way that I like thinking about this is the word line is literally right in the word linear. So when you see linear, you basically just want to think a straight line. So linear function is an equation that can be written in the form f of x. So normally we would write previously up to this point, we would write y is equal to mx plus b. In this case, we're just going to change it to an f of x. F of x is equal to mx plus b. It's called a linear function. So they either rise or fall. They have a positive or negative slope, right? And that was kind of the thing I was mentioning last time. When you're looking at the behavior of certain functions, are they increasing or decreasing? You can kind of think of those as like having associated with like a slope. And so there's actually more a formal definition of increasing and decreasing that actually comes from calculus. If anybody goes and takes calculus, what you'll actually see, and again, this you don't need to know this for this class, but there's something called a tangent line, and the tangent line touches the function at a single point. So what you're doing is you're calculating for increasing and decreasing all of the tangent lines. The tangent line is just, again, it's a straight line. So depending on what your slope of the tangent line is, that's how you can determine whether or not something is increasing or decreasing. So that, again, that's kind of a look ahead to some future classes if any of you are going to take calculus. So the slope, we always use the letter m to represent slope. The slope of a line passing through the point P1. So again, we've kind of done this before, x1, y1, x2, y2. If you recall back to when we looked at distance and midpoint formulas, we were again just kind of using these same kind of ways of writing these. x1 and x2 can't be the same. The reason why is because if they were, notice what happens. You'd have a zero denominator. We can't have that. By the way, if you have a zero denominator, you would actually have a vertical line, which is this guy right here. It's a specific case of a very specific line. So I like to call these, so these are delta y and delta x. This is kind of a shorthand way of writing it. Delta is a Greek letter that we use to represent change. So the change in y or the change in x. I don't know if anyone has ever, if people are interested in rocketry. Here's a perfect example. NASA, when they're determining how much fuel they have for specific burns to put spacecraft into space or to bring them back, the engine needs to burn and it needs to use a certain amount of fuel. So what they use is a term to determine how much change in momentum or how much velocity they can produce, and they use actually a term called delta V, which is a change in velocity. So delta is something that shows up all over the place. It just represents, again, differences in quantities or a change in a variable. Vertical lines, again, I just mentioned it. It has a zero denominator, so we call it having an undefined slope. Zero denominator, I should say, is in the slope equation. It has an undefined slope. Horizontal lines are the kind of reverse. So you've got your vertical lines, which are up and down. Your horizontal lines are side to side. your numerator is actually just going to be 0 in your slope formula. So that's how you can distinguish between horizontal and vertical lines if you do have a 0 somewhere. 0 in the numerator means you've got a horizontal line. 0 in the denominator means you have a vertical line. What if you have both? I'll leave that as an exercise to you to go look up on your own. All right, let's go ahead and move on. Slope-intercept form. So the two different ways that we generally write lines are going to be in slope-intercept form and point-slope form. Slope-intercept form is your classic equation of a line, specifically with regards to f of x is equal to mx plus b. Your y-intercept is going to be at the point 0b. Your slope is going to be m. So again, this is really helpful when you want to know when it crosses the y-axis. Point-slope form, if you don't have any, if you don't have a point that crosses the x-axis, or I'm sorry, the y-axis, if you don't have a point that crosses the y-axis, but you're given a point somewhere else in a slope, you can actually substitute all those values in right here and still get an equation for a line. When you go and simplify, you can literally take this form and simplify it into slope-intercept form after you sub those values for x1 and y1 in. And again, we'll do an example of that here in just a minute. Parallel and perpendicular lines. Okay, so parallel lines have identical slope. Okay, when you're dealing with parallel and perpendicular lines, you're only concerned with the slope. You don't have to worry about the points or any other value. You are only looking specifically at the slope. Okay? Now again, I've got kind of fancy language here. The one thing that you need to just bear in mind when you're dealing with slope for parallel and perpendicular lines is that if you have two lines that have exactly the same slope, they're parallel. If you have two lines that have different slopes, but one of the slopes is going to be the negative reciprocal of the other, then it's perpendicular. So for parallel, you think same. For perpendicular, you think negative reciprocal. Remember, negative reciprocal means you take the slope, you flip it so it's in the denominator, and then you make it negative. Okay? So you're essentially turning your slope into a fraction. Or if it already is a fraction, you just flip the numerator and denominator. So for example, if I have a slope that's, say, negative 3/4, if I wanted to do the negative reciprocal, let me rephrase. If I want to do the negative reciprocal of the slope of negative 3/4, it would become positive, and the slope would become 4/3. That would mean then that my lines, if I have those two slopes, they would be perpendicular to one another. Again, we'll go through an example, so hopefully you can see what I'm talking about. All right, let's go to our board here real quick, jump into some examples. So again, this is section 2.3. Let's look at question number 6. This pen, this marker seems to be a little on the light side here, so let's try to find another one. Not that one. Yeah, we'll use this one. This one works. All right, 6. Section 2.3. We need to find the slope and y-intercept of this particular function. And the function is y equals 3 minus 2x. Okay. I actually open my book to that section so I can make sure I'm reading the instructions correctly. 2.3. All right, so the slope and the y-intercept, the coordinates of the y-intercept. Now notice the slope-intercept form is y is equal to mx plus b. So if you see something like this, what you can do is just reverse it. This is the same as minus 2x plus 3. Okay? So this right here means that m is equal to a minus 2. And the 3 right here, that is actually going to be the y value of our y-intercept. So in other words, the y-intercept remember, y-intercept, the x value is 0, and the y value is going to be what that guy is. So it's positive 3. Okay? So that's our solution. Again, we're just looking for the slope and the y-intercept. My eraser. All right. Next question. Question number 10. This is asking us to determine whether or not the lines are parallel, perpendicular, or neither parallel nor perpendicular. So question 10, we've got y is equal to minus 2/3 x plus 1, and y is equal to 2 minus 2/3 x. Actually, I think the way that they wrote it is this. It's the exact same thing. You're actually going to see this here over 3. Okay. So again, remember, y is equal to mx plus b. So let's just put this in the proper form. The first one is already done. The second one, we just have to change it. So this is going to be y equals minus 2x over 3 plus 2. Okay. And notice this is actually the same thing as minus 2 over 3 times x plus 2. Okay. So when we're looking for parallel and perpendicular lines, we're comparing the slope, and because these are the same, the slope is the same. So that means it's parallel. The lines are parallel to one another. All right, so that's question 10. Perpendicular, again, it would be a negative reciprocal. Let me go ahead and show you one of those real quick. I'll just do question 12. So question 12, we've got f of x. Remember, f of x is the same as y. 4x all over 3 plus 2. And I'll do them next to each other this time so you can see. This is equal to 2 minus 3 over 4 times x. Okay. So again, let's just put this in the proper form. Remember, y is equal to mx plus b. So this means that we need to bring that to the front, minus 3 over 4 times x plus 2. And similar to what we did in the last question, let's do this. 4 over 3 times x plus 2. That x can just come down next to it as a multiplier. That way the form is pretty similar. So again, we're going to compare the slope, and you can see the denominator's flipped and it's negated. So that means that this is perpendicular. So the slopes are negative reciprocals. So perpendicular. All right, so that's question 12. Let's go ahead and jump to question 14. This one's going to ask us to find the slope of the line that passes through the given points. All right. So 14. First, let's just remember the equation. So delta y over delta x, which is the same as y2 minus y1 all over x2 minus x1. Something to bear in mind, the order does not matter. You can put them in any order for the, well, they need to be the same. I should rephrase. You can do y1 minus y2 or y2 minus y1 as long as the bottom matches the same. So the points that we're given here, let's just go ahead and write them up here. So point 1 is going to be question 14, minus 2, 4. And point 2 is equal to 5, 1. Okay? So I'm going to just say x1, y1, x2, y2. Right there, those are the values. And then we can go ahead and just substitute them in here. So y2 is 1 minus y1, which is 4, all over x2, 5. And we're subtracting a minus 2. Okay? So 1 minus 4 is a minus 3. 5 minus a minus 2 is 5 plus 2, which is 7. So this right here is equal to m. That's our slope, minus 3/7. All right, 24. This one's asking us to, let me see. Do I want to jump to another one? Let me do, yeah, I'm going to do another one. I'm going to do 38, something that's a little bit more complicated. Let me look here. All right, let's go ahead and erase. Question 38. 38 is asking us to graph each equation by first writing the equation in slope-intercept form. So we're given 2x plus 3y plus 6 is equal to 0. So we need to convert this into slope-intercept form. So remember, slope-intercept form is y is equal to mx plus b. Okay? And when we get done, then we'll go ahead and plot it so you can see what that would look like. Again, you get to see my awesome drawing skills. So when you have something like this, the goal is to get everything except for the y on its own side. So we're going to keep the y here, and we're going to move the 2x and the 6 over to the other side. So they're just going to be negatives of each other. Okay. So now that we have this, we need to get rid of that 3, and the way to do that is just divide everything by 3. So you can do this divided by 3, this divided by 3, and this divided by 3. Okay? So y is equal to minus 2/3 x minus 2. 6 over 3 is going to be a 2. All right, so how do we plot this? This is going to be interesting. Trying to do this freehand, and I have no straight edge in front of me, so yeah, should be fun. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. All right. My scale might be a little off, but we'll just see how it goes. All right, so the slope is minus 2 over 3. The y-intercept, this is going to be 0 minus 2, which is down here. All right, so when we have a slope of minus 2, 3, you can think of it as like rise over run. So that's like another term for saying like your directional change in the vertical is on the top and the directional change in the horizontal is on the bottom. So you can think of this as going down 2, 1, 2, and then over 3. Wait a minute, hang on a sec. Change y over change next. Yeah. Yep, okay, so sorry, I'm brain fart. That happens. Minus 2, down 2, 1, 2, and then you go over in the direction 3. 1, 2, 3. Here it is. Okay. So this is the point, 3 minus 4? Okay. So the line should go right through that point. And now if we wanted to go in the opposite direction, you can think of it as like flip this negative sign into the denominator. It's the same thing. So you go up 2, 1, 2, back 3, 1, 2, 3. This guy right here. And again, if I am... that's pretty good, actually. I'm not bad at my drawing. All right, so there's our line. So you can kind of see what happens when you do that. You're changing, again, the only reason I did that is because I wanted to go up and back and then down and over. It kind of works out the same way. So that's how you would go ahead and plot one of those. All right. Another cool little trick, especially when you're working in WebAssign, is you can find the intercepts. If you remember, go back to the section where we talked about X and Y intercepts. And what you'll notice is in WebAssign, you only need 2 points to plot a line. So if you find the x-intercept, you can put a point there. If you find the y-intercept, you can put a point there. And then it should plot a line that goes straight through it. So you don't actually need to do the rise over run kind of change, kind of like what I just did right there with slope. You can literally just find the intercepts and it should plot it automatically. All right, so 48. You know what? Actually, I'm going to skip that one because that one's really easy. I'm going to go to question 56. These are a little tricky because what they're asking you to do is to find the equation of the line in slope intercept form. They only give you conditions. They don't actually tell you anything. Like they won't give you like, hey, it's this form and convert it. So let's just look at 56. You'll see what I mean. So 56 says the graph is parallel to the graph. So parallel to y is equal to minus x plus 1 and passes through the point minus 2, 4. All right, so in this instance, what we're going to do is we need to remember our point slope form. Our point slope form. So that's, remember, y minus y1, or y minus y1 is equal to mx minus x1. Okay? So this is point slope form. Our y value and our x value, so this is our x1, this is our y1. So what do we have? We just go ahead and substitute these values into our equation. The question we have to ask ourselves is, what exactly is the slope going to be? Well, the clue is given in that it's parallel to y is equal to minus x plus 1. So if it's parallel, that means that it has to have the exact same slope. So the slope in this case, m, is going to equal minus 1, and the point is going to be the point minus 2, 4. Which means that if I substitute these values in, I'm going to have y minus 4 is equal to m times x. And this is going to be plus 2 because I'm doing a minus 2. So the question asked us to put this into slope-intercept form. So this is point slope. We need to get it into slope-intercept form. So the goal... Let me write this down here. Goal is y is equal to mx plus b. Okay? So we need to kind of work to that goal. And the way to do that is literally just multiply everything out. I forgot to substitute my m. This is a minus 1. There we go. So we just multiply it out and move things around. So what I'm going to do is I'm going to take this 4 and bring it to the other side. So y is equal to minus x. I'm going to multiply this out also at the same time. So it's like 2 steps in one. Minus 2, and then I add 4. Okay? So y is equal to minus x plus 2. So right there, that's our solution, and it matches the form that we asked. Okay? So that is that question. And that's pretty much it. That's what we have for linear functions. So if anyone has any questions, again, shoot me an email, and I'd be more than willing to work with you, answer any questions you might have. But aside from that, I hope you have a fantastic day.